We're about to follow the secret life of a computer chip you can actually buy online for your next project. It's a story that kicks off on a simple workbench, and believe me, it ends in a place you would never, ever expect.
You know, if you're a maker or an engineer, this is a classic debate: Raspberry Pi or BeagleBone. It's a choice you usually make sitting at your desk. But what if I told you the answer to that question has implications that reach, well, low Earth orbit, and maybe even beyond? So, here's how the choice usually breaks down. The Raspberry Pi, it's the friendly all-arounder. It has this massive community. It's perfect if you're building a home media center or just learning to code. The BeagleBone, though, that's the specialist's tool. It's built for getting its hands dirty with direct hardware control, which makes it an absolute powerhouse for things like robotics and real-time applications. Today, we're going to zero in on that specialist. We are going to peel back the layers on the BeagleBone because we need to see what makes it so different and, as it turns out, so incredibly powerful. And here it is, in all its glory. This is the BeagleBone AI64. Now, I know it might look like just another circuit board, but as you're about to see, this little open-source computer is hiding some serious capabilities. Right at the very heart of this board, you've got the brains of the whole operation. It's a system on chip, or SoC, from Texas Instruments, and it's called the TDA4VM. Remember that name, because it's the real star of our story today. So what exactly is a system on chip? Well, think of it this way. It's not just a processor. It's literally an entire computer system. The CPU, GPU, memory, the whole shebang, all crammed onto one tiny piece of silicon. This level of integration is what makes powerful little devices like the BeagleBone even possible. And this particular chip, the TDA4VM, it has this special talent. You could even call it a superpower. And that superpower is its performance with artificial intelligence. 30 times. Just let that number hang in the air for a second. What do you think that means? It represents a truly colossal leap in performance. But where on earth does that kind of boost come from? Well, the secret is a clever bit of software called the TI Flight Delegate. Think of it like this. Instead of forcing the main processor to do all the heavy lifting for AI calculations, the delegate says, nope, I got this, and offloads all that hard work to a dedicated, super fast AI accelerator that's built right into the chip. It's really the difference between using a Swiss Army knife for a job versus a specialized power tool. And the difference is, honestly, it's staggering. Without that delegate, the chip chugs along, maybe processing 6 or 7 frames per second for an AI model. But turn the delegate on, it can run complex object detection in just 6.5 times milliseconds. That right there is where that insane 30x performance boost comes from. Okay, so we've established it's fast, it's an AI beast, especially for a hobbyist board. But what about resilience? I mean, how tough is this little piece of silicon really? Well, that very question of toughness is what caught the attention of NASA, and they decided to test this little chip in one of the most extreme, punishing environments you can possibly imagine. And no, this isn't some rendering or simulation. This is the actual BeagleBone board, the same one we saw earlier, mounted in a test rig at a national laboratory, about to get subjected to something incredibly intense. The plan was as simple as it was brutal. To see if this chip could survive in space, they were going to simulate years of cosmic radiation in just a matter of minutes. And the method? Well, you fire a beam of heavy ions. We're talking super fast, high-energy particles directly into its core. This setup here just shows you the sheer engineering that was involved. On the left, you see the diagram, this complex web of power supplies and data capture, all designed to monitor the chip's health while it's being bombarded. And on the right, you see the reality, the board, just sitting there, ready for the test, just centimeters away from the beam. Now, during the bombardment, engineers were watching its vital signs like a hawk. This dashboard right here is showing the chip's power consumption in real time. They were looking for any sudden spikes, any weird drops, any sign at all that the radiation was causing a destructive, catastrophic failure. And after all that, the official verdict, straight from the NASA technical report. Despite being blasted with radiation, and I quote, the TI-TDA4VM system on chip did not experience any destructive events. Just let that sink in. An affordable computer chip designed for a hobbyist's workbench just proved it was tough enough to survive the harsh vacuum of space. It survived.
And this wasn't just some random science experiment. NASA had very real goals in mind. They were seriously evaluating this chip for things like general computing on satellites, driving the displays inside an astronaut's helmet, controlling interfaces on rovers, and even running AI models in orbit. So let's bring it all the way back to where we started. That simple choice, right? Raspberry Pi versus BeagleBone. Suddenly, that decision feels a whole lot bigger, doesn't it? It's not just about what your next home project is going to be. It completely reframes what's possible. The same exact tech that can power a little robot in your garage is tough enough for an astronaut's suit. So, the real question for your next project is, are you building a media center or are you prototyping a satellite?